Today, your mission will be to implement a DFA that accepts words with at least 2 consecutive bits. In this case, the alphabet consists of 2 symbols, the symbol A and the symbol B. Let's take a look at some examples of valid and invalid words. The first one is a valid word because it already contains 2 consecutive bits. This word is not valid, even though it has 2 bits, they are not consecutive. The next one, ABBA, is a valid word because it contains 2 consecutive bits. Note that after we have satisfied the condition, we can have anything we want in the right-hand side of the word or in the left-hand side of the word. The next one, BBBAB, is valid because we don't have 2 but 3 consecutive bits. The next word consists of a single symbol, in this case A, so it is not valid. This is the epsilon symbol, and I will be using this symbol to denote the empty string. An empty string is not valid because it has no elements or no symbols, and thus no bits. Before implementing the automaton, we need to design the actual automaton. I will start by creating the initial state, and I will call it capital S. I'm using this arrow to denote that this is an initial state. Then I'm creating another state called B. Whenever we arrive into this state, we know that we have already read 1 consecutive B. So if we are at the initial state and we read 1 B, then we will arrive at this state. Next, I'm going to draw another state, and this will be called double B. Once we arrive at this state, we know that we have already read 2 consecutive Bs. At this point, we have already satisfied the condition, so I will mark this state as a final state. So if we are in the initial state and we read a B, and then we read another B, then we will be in a final state. And at this point, our word is valid. Note that we could also have something like this. We have 2 Bs, and then we can have any number of A's or any number of Bs in the right-hand side. To account for that, I'm going to add a self loop in the final state, or a self transition, either with A or with B. Then before the double Bs, we can also have any number of A's at the beginning. So to model that situation, I'm going to add a self transition in the initial state with the symbol A. And finally, after we read a single B, if following there is an A, then we need to go back to the initial state. For example, if I read a B and then there is an A, I need to go back to the initial state so I can start counting the Bs from the beginning. So this is our final automaton that we will be implementing in Java. Typically, you will find that automatons are implemented using matrices. The transition table is implemented as a matrix. In this case, I decided to implement it as a graph. To me, it sounds more natural because this diagram is already a graph. We have nodes and we have transitions. So I will be implementing this using a graph data structure. So to proceed with the implementation, I'm going to open NetBeans. So now I will create a new project. I will leave the default name and click Finish. I will delete these comments, and I will change the name of the file to main. Just to check that everything is working correctly, I will run this file, and this should print hello world. And here it is. Okay, the main program is working. Now I'm going to implement the states and transitions of our automaton. First, I'm going to create a class that will store the values for the state. In this case, the name of the state and whether or not this state is final. So I will create a new class and we'll call it states. Here I'm going to define two attributes. The first one is a string and corresponds to the name of the state. And the second one is a Boolean variable that will tell me if this state is final or not. Finally, we need a way to store the transitions. Let me go full screen here. I'm going to implement the transitions using a hash map because then we can access them in constant time. So I will create a hash map. And the first element will be a string. And the second element will be the state. And I'm going to call these transitions. So the string or the symbol is the key and the state is the value. I'm going to create the constructor. So I go to source, insert code, constructor. So I can initialize the name and the type of a state. And finally, I'm going to create an empty hash table every time I create a new state. So I'm going to initialize these transitions into an empty hash map. And we are done with our construction. Next, we need a way to add new transitions to our states. To do that, I'm going to create a new method called addTransition. The method won't return anything, so I will just write void. And this function will receive two arguments, the symbol and the target state. So this method is just a wrapper for the put function of the hash map object. Now, I also need a way to retrieve what's the next state given the current symbol. To do that, I'm going to create a new function or method that will return the target state given the symbol, and I will call this one get next state. And the only argument will be the symbol. And this is again just a wrapper function for the get method of hash map. Please note that if the symbol does not exist, the hash map will return a null value. So we need to take that into account, and this is going to be useful later on. Finally, I would like to debug my program, so I will overwrite the toString function. Every object in Java has this function. So in this case, I want to print the name of the state. And I want to print if it is final or not. And finally, I'm returning the string s. So let's test our class. I'm going back to our diagram. So we have 3 states. I'm going to create the initial state. And its name will be capital S. And this is not a final state. This is not a final state. And I'm going to print my object. So it prints the name and the type of node. In this case, it's not a final state. Now I'm going to create the remaining states. State B. This one is called lowercase b, and this is not a final state. So I pass false as its value. And the last one is a final state, so I'm passing through here. Now I'm going to start adding the transitions. From state S, if I read an A, I stay in the same state. And if I'm in S, if I read a B, I will transition into state B. So let's add those transitions. I will use my method add transition. If I read an A, I stay in S. If I read a B, I will transition into state B. So now I'm done with S transitions. Now I'm going to add transitions for the next state. If I read an A, I will go back to S, and if I read a B, I will transition into double B state. So if I read an A, I will go back to S. If I read a B, I will go to state double B. And finally, when I'm in the final state, if I read an A or a B, I will stay in the same state. If I read an A, I stay in double B. If I read a B, I stay in the same state. So I'm done with my states and my transitions. Let's test. If I'm in S, and if I read a B, this should return state B. So let's run the program and see what's printed out to the console. So this one is printing state B, which is correct. So now we need to add our algorithm that will actually check if an input word is valid or not. To do that, I'm going to create a new class, and I will call this one automaton. This class will store the states and the transitions. In this case, I only need one attribute, and it's going to be the initial state. I'm going to create the constructor here. So I can initialize my automaton with the initial state. And finally, I will need a function that will actually validate the input word. This one will return a Boolean value telling me whether or not the word is valid or not. I will call this one is valid. And the only argument is the word that I want to check. So first of all, I need to check if the word is empty, or this is the empty string. If the word is null or if it is empty, I need to do something here. In this case, the initial state is not final. So this automaton does not accept empty strings. But it could be the case that this state is also final, in which case the automaton would accept empty strings. We want to make our code general, so we will implement both cases. So we need to check if the initial state S is final. If it is final, we should return true. If it's not final, return false. Next, I'm going to create a Boolean variable, and I will initialize it to false. This variable will keep track if the word so far is valid or not, and I will keep updating this variable as we read symbol by symbol. And finally, I'm returning this variable with the final answer. Next, I need to iterate each symbol from my input word. To do that, I'm going to create a for loop. And I'm going to extract symbol by symbol from my input word. To do this, I will use the substring function. And I will pass the index and 1 plus. This will have the effect of returning every symbol in my input word. Let's test this. So I'm going to print every symbol and see if this is working. I'm going to my main program. And I'm going to create an object of type automaton. And I'm passing the initial state. Next, I'm going to create the input string. This is the user input. And first, I'm going to try with ABCD, for example. And I will print the result of the isValid function. In this case, it should print the list of symbols, ABCD. So far it's working correctly. I will continue implementing the logic of our function. I'm going to delete this because we don't need this anymore. So first of all, we need to transition from the current state to the next state. And to do that, I'm going to keep track of the current state. So I'm going to create a new variable called current state. And at the beginning, this will be equal to the initial state. And then in each iteration, I will update this state with the next state given the symbol. We need to check if the next state, or in this case the current state, is null. This means that the symbol does not belong to our alphabet, and we should return false. If the current state is null, we should return false. Now we need to check if the state is final or not. If the state is final, it means that so far the word is valid, so we should update this variable to true. Otherwise, we set it to false. The current state is final. And we are done with our implementation of the isValid function. Let's test it. I will pass an input string, so this one should return false. So far it's working okay. Now I'm going to pass an invalid word, for example AB. And it returns false. Now I will try with a valid word. The simplest one is BB, so let's do that. And it returns true. Now I try something else. For example, AA, BB, AA, B. This one should return true. And it's working correctly. So this is how you implement an automaton in Java.